Okay, so we have Python. This is our third review session on Python, so hopefully we get, a much more accommodated with Python this time around. So what is Python? Once again, it's an object-oriented programming language. You have objects, which I just explained before, which are data structures that contain information. So in an object, you have two components: object name and object value. The object name is the name of whatever you want to call it. So in math class, if you had x equal to 7, x would be the object name, 7 would be the object value. You have other examples like lists, where the object value would be the series of numbers or variables, and your object name would be the list name. In cases like functions, you would have a function name, like what we did last time with final grade calculator. Your final grade calculator would be your function name, and then your actual object value would be all the stuff inside of that object name. So all the steps that you had to take, that big equation that we solved for final grade calculation, that would be your object value. For variables, it's a lot easier. You just set something equal to one variable: a float, a string, a boolean, an integer, anything like that. You can set some object name equal to that. And that's a quick overview into what object-oriented programming language is. Level of Python, once again, we're up here. I'm pretty sure you guys seen this enough. Applications of Python. Once again, scripting language, good for data analysis, scientific research, and it's used in some other instances like Battlefield 2, video games, etc. Accessing Python. Go to terminal. We all know how to access it. I'm pretty sure everyone's good on that. Lesson plans. We're just going to use this as a quick review. What does a print function do? Starting down there. Yeah. So it basically prints out whatever you give it. It could be a variable name. So you had a variable name and it would print out the variable value for you. If you gave it a string, it would print out that string. If you gave it an integer or a float, it would print out that float or integer. Calculations. Luke, name the one calculation that's not on there that we covered. Yep. So exponents would be double asterisk, yeah. And then Saxon, go over these ones that we have up there.
Plus is just when you're adding two numbers together. Minus is subtraction. The slash is for division. Asterisk is for multiplication, and the percent is for remainder.
Yep. And what if you divide something like 9 by 4, and if you were just using pure Python, not some development environment? What would happen?
You would get 2.
Okay, that's good. It only takes it integers. It basically takes as much as it can for that number, and then it doesn't account for that remainder. Variables we went over, but let's just go over them real fast. Right down there, name all 4 variables. Yep. String, boolean, float, integer. What is a list? Yeah, it's basically like a sequence of variables, and sometimes the order does matter if you're going to loop through it or something like that later on. It's usually just all integers, all floats, all Boolean values, all a list of lists. You can actually have that as well. So usually called arrays, where you can stack them on top of each other. So like the matrices, have you ever seen those, where it's like a bunch of lists together? That's how you would manage that. So list is basically a list of variables, but you also have to keep in mind that you can also have a list that doesn't have just one type of variable. You have a string, comma, integer, comma, a boolean, then comma, another integer, comma, a float. So it could be a lot of different variables put together, but most of the time you would be right to loop that these lists are usually just of one type of variable. And now here, other commands. Just name one of the other commands we covered.
Define function.
Right. That's a function command, so DEF would define a function.
Round.
Round, yeah, that's another one. Where you have a float number, comma, your next parameter is how many decimal points you want to round it to. So if you put 2 down, it would round it to 2 decimal points. And down there, name one more function that we covered. range. That would give you a list basically of that many numbers starting from 0. So range 5 will be 0, 1, 2, 3, 4. And it's a hard one. There's only one left. Do you remember it? Length. Yeah. LEN. It will give you how many members are in list. And that's really good for, kind of understanding how big is my list, what do I need to do to get it down, just to really see how big your list is, what it looks like. That's usually a pretty powerful function. Okay, so from that, it seems like everyone understands print, understands calculations. We don't even practice. Integers, floats, strings, booleans. Just go over these. Let's just go over these real fast. Pretty sure you guys have this, but just in case. First one. Yep. Second one. Yep. 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 So the last two are a little bit trickier. They're supposed to be tricky, but you guys have already seen the tricks of them 2 times already. So. Oh yeah. So they're a little bit. So you gotta keep that in mind. So a lot of times when you're programming something, you're like, wait, why didn't that work? You check back and be like, oh yeah, I had a float and I was trying to do some integer stuff with it, or I had a string and I was just adding it to a float or an integer, and that's why I have an error. So you gotta make sure your variables are the same when you want to add them together. Okay, so these I covered them a few times, but it seems like every time we go back over them, it seems like there's usually a lot of confusion over kind of what these do most of the time. So just a quick overview. Int is abbreviation for integer, and whatever variable you put inside of it, it's going to cast that variable into an integer, meaning it's going to take that variable, and if it's possible to make that into an integer, it's going to make it into an integer. So if you put int string 5, it's going to cast that into an integer 5. If you do int 5.00, it's going to cast that into the integer 5. If you get a 4.2, it's going to cast that into 4. That's what an integer casting function does. The string casting function will take anything that you give it, and add basically quotation marks around it and make it into a string. That comes in handy when we're doing that final grade calculator thing where we want to print out, or most functions where you want to print out a number and then something afterwards like 5 is greater than 5 or 5 is less than 10 or something like that. You would definitely have to cast that 5 from an integer into a string and then add it to that string that you write out later on. So that's basically how strings casting function works. Float casting function, you do that to cast an integer into a float. That's usually pretty useful, especially when you want to do that kind of precise division and precise remainders and stuff, and you don't want to do that kind of rounding stuff that the integers default to. So those are the 3, and quick review. Int, what does it do? Yep, makes it an integer string. Yeah. And then float.
It makes a float type of integer or variable.
Yeah. So pretty easy. Just keep those in mind when you want to change some stuff around because they come in handy. Lists. Okay, so we already covered this. Remember the keyword is called instantiate. That's what you do when you set an object name equal to an object value. So when you set x equals 7 or list is equal to 1, 2, 3, 4, or def function, your instantiating function, you're instantiating a variable, you're instantiating a list. That's where instantiation comes into place. Some examples: 1, 2, 3, 4, 5. A list of strings: 1, 2, 3. A list of booleans: true, false, false, true. And then a list of floats: 1.0, 2.0. And then keep in mind that you can have different lists. So you have like 1 string, comma, false, comma, 2, 3, comma, 2.00. So you have a list of different kinds of values. So these are the other commands: range, length, and round. So we covered these already in that review session. So if you guys are still a little bit confused about these, just look up there for a bit. but it looks like everyone's good. Loops. Used to perform a given action on each member of a set sequence or list in a given sequential order. So that's when the list order comes into play, because you're going to go to the first item, then the second item, then the third item, and so on and so on. So the order does matter when you're putting items in a list and when you're trying to loop through that. So let's go with Luke. What does a for loop do? Like if you had Yeah, so it'll run through the list that you give it. It doesn't have to be integers. It could be, I think you were trying to just mean like variables in general, but it could be strings. It could be something. Most of the time, it is integers, just because they usually do some calculations with it. But you could do floats. You could do a lot of different other types of numbers and variables as well. And then you just run a few commands through them, and they loop through. So they go to the first one, then the second one, then the third one. And then when it reaches the last one, it says, oh, I'm done, and it spits out, it basically doesn't spit out anything, it just stops the function. So here's an example for color in red, blue, green. And these are where they have strings. You just print the color, so it goes in. And remember, for and in are the big keywords here. For and in are keywords in the for loops. So you go for color in this list right here. So go to the first item, set color equal to red. So instantiating the variable color into the object value or variable value of red. And then it's going to print color, which is equal to red. It prints out red. And then it sets color equal to blue, prints out blue. Then goes back, sets color equal to green, prints out green, reaches the end of the function, and then quits the function. And you have these outputs right here. Same thing here, just a bit more complicated. For count in 1, 2, 3, this is where we have integers in our list. It's going to instantiate the variable name as count, and then do some other stuff. And as you see, there's a for and an n. Those are the keywords. We've seen this example a few times, so does anyone want to explain it to me? Luke? That many times. Yeah. So that's basically it, where you set this equal to each of these respectively. Then because this is equal to this, then equal to this, then equal to this, you're going to print 1, 2, 3. Then you're going to print yes 1 times, 2 times, 3 times, yes, 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 yes. So that's basically it. Seems like everyone has a good understanding. Saxon, was that what you were going to basically iterate to?
Pretty much.
And down there, you guys all good? Everyone
got it.
good? Well, there's multiple people down there.
Yeah.
If loop. This is the second type of loop. Can anyone explain, before we go on to example, just kind of a brief explanation? And Luke's off the hook because he answered the last one, so out of everyone else?
Just the if? Or all three?
Just all three of them together. You just call that the if loop or if statement, but just basically kind of run down what it does.
Well, it just kind of sets a situation, I guess, so like, for example, if one variable equals another, or if you reach this item in the list, then you set up some sort of condition which will follow that. So if x equals 2, you'll go like hit enter, then tab over, print x equals 2. Else if, basically, it's just the default other option if x does not equal 2, or something else. If your first kind of qualifier isn't acted upon, then this one just says, okay, let's try this again. Does x equal 9? And so, no, that's else. Else if means just like if it doesn't equal 2, then it'll just put anything else. So if x equals 2, enter tab, print x equals 2. Else if x doesn't equal 2 or something like that, enter tab over, print does not compute. And then else is when it specifically does not meet the first variable And so it's not just a default generalized statement, it's if it's in contrast with the first statement. So else just print x is greater than 2 or something like that. It's kind of just like a triple layer way to get through a list or some other variable and kind of organize it like that.
It's close. I don't know if you, else if is more specific than else statement. So else if is so imagine like this, like imagine like a filter, like last time I talked about filter. Once you filter a number, so you have your list of numbers and you can basically sprinkle that on top of this filter, and whatever gets on top, whatever gets caught by the if statement, whatever fulfills that if statement is going to get caught, and it won't even be read by anything below it. If that makes sense. So like even if else if it fulfills the else if statement, it's not going to go down to the else if statement if it gets caught by the if statement. That kind of makes sense. That kind of makes sense like, in terms of like that. I don't know if that's a good analogy to use, but then the else if statement is another filter, and at the very bottom you just have your coffee pot, and that's your else statement that catches everything basically. So it's a little bit more complicated than your for and in loop, just because it's a little bit think a little bit about it. But here's an example, a pretty complicated example, but we'll go through that real fast. But Saxon, you basically have the general idea down for most of it, so you seem to be good. Can someone explain this example, or try to explain it? I know it's a little bit more daunting than the typical examples. Yeah, you can go ahead. You can move up if you can't see.
First, you define what the list is. So you name big list, name all those members, big list. And then for x, just a variable in big list. And you go if x is greater than that.
Are you just reading this?
Well, what else?
Okay. All right, keep going. Keep
Then
going.
it'll print, and then otherwise, so if it doesn't meet the x is greater than 4, if it's x is less than 2, then you print x is less than 2. Then if it doesn't meet any of those, then it prints it doesn't belong.
That's basically a rundown of it. You're going to go through this list, big list. You instantiate it as a variable, actually a list name. It's equal to the list value right here. And then what are the two keywords here, guys, that you see in this line? For and in, yep. So x is going to be instantiated equal to each of these respectively by their order. Then it's going to run through here. Filter number 1, is it bigger than 4? If it's not, it's going to move down. If it is, you're going to print x is greater than 4. Filter number 2, if it goes past filter number 1, is it less than 2? If yes, print x is less than 2. Otherwise, if it passes both of these filters, you're going to print the string casting function of x. So it's going to turn whatever number is up here that x is set equal to into a string. So it's going to be like quotation mark 5 in quotation mark plus, quotations doesn't belong. So that's where you have this output down here. It runs through. We've done this example a few times. Just by a vote of hands real fast. Do you guys want me to explain each of these functions, or are we just good on that individual output stuff? Who wants me to go over it in more detail? Okay, so it looks like everyone's good. Okay, so functions. So functions create a callable command, which is a command. Okay, so what is a callable command? Like we covered a bit about functions, but what about functions makes them better than just writing out everything that's in a function and just doing that?
A callable command is basically sort of a template you set saying, I am defining this function as, and you input all the commands you want. So that way, if you plan to reuse it ever again later in the same code, you don't have to rewrite every single bit of code. You just write the function name and still have the computer get what you mean.
Yeah, that's exactly correct. Functions are used because they are efficient. They save time. You don't have to do the same thing over again. And once you get it right, you get it right forever. So like, kind of if you were using the quadratic formula or something like that, or even in math class, let's say if you could just do one problem right, and got that method down, then you can just apply that to every other math problem and get 100% on that test. That's a pretty good deal if you ask me. So that's kind of the same thing with functions. You get it 100% correct the first time, then you can use it over and over again, infinite numbers of times, and still get the same very powerful function that you write. So kind of the setup, you have a define, that's your kind of your keyword there, DEF. You define the function, you just call it whatever you want to call it, and keep in mind that when you want to recall this function, so when you want to use that function again, basically what you would type up is this portion right here, without the colon at the end. So you would type in your function name and then your parameters, which would be some variable value or any types of data values in here. But in this case, when you establish a function, where you instantiate the function, your parameters are going to be general variable names that you're going to call upon down here in commands, more commands, and then you can return something that you set equal up here. So it's going to be some object name that you're going to return. All right. Functions example, we've done this example a few times, pretty easy. Define, your keyword right there, and then your function name is going to be describe, parentheses, your two parameters, which are just anything you want to call them, some variable names, name, comma, trait. And then description, you hit enter with a colon, enter, tab into it. Description, which is a variable name that you instantiate inside of the function, you set that equal to name, which must be a string up here. So keep in mind that if you describe something and you don't have a string like I do right here, then you're going to have a problem up here because it's going to try to look for the variable Eric if this isn't in quotation marks, and it can't find that, so it's going to return some kind of syntax error. And then over here, we just added to a few different, two different types of strings, and make sure your trait, whatever you put up here when you call upon this function, is also in quotation marks. And then we return our description, which is all these strings added together, which is just one big sentence, if you want to think of it like that. And that's what we return. So when you hit the function, it's just going to print this out for you. So does everyone want to try that out again? Because I know functions are fairly new, because I think we started covering that last time. So, and if you have any problems, just let me know, and I'll come by and check it out. By the end of today, if you guys feel pretty comfortable, and we can do that final grade calculator again, and then I'll have you guys look at that piece of code I wrote, and then if we look like we're pretty, we're all on the same page, then we might cover some information on Python classes, which, I mean, they're not very pertinent when it comes to Python programming right now, when you're just writing simple lines of code, one function, or just a few things for calculations, but they do come in handy when you're trying to develop a bigger program that's going to have multiple functions, multiple variables, all of that, and you want to keep that inside of one class to kind of organize it. That's when it comes into handy. So hey, does anyone have problems, or is everyone pretty good? Is it working for everyone, or do you need some more time?
You good, Tony?
I'm having an issue.
shoes. Oh, no.
You're going to put a string variable. Now, if you didn't want to make them quotation marks, then you can cast them into a string value inside of the function, but that just makes it a little more complicated. So for our sake, just input string variables for now. But everyone else good? Luke? Saxon good? All right. Tony good now? Okay, so spelling is very important. You just noticed someone in this room, instead of saying describe up there, they put describe without the S. So when you and then they call it describe. So you can't call upon a function that doesn't exist. And if you were working with humans, it might be like, oh, you just spelling mistake. That's all right. But when you're working with computers, they don't differentiate between properly spelled stuff and improperly spelled stuff. So you had to make sure it's exact. Low batteries. Someone have a charger I could borrow?
Yeah,
Very reluctant.
Gotta be prepared, Eric.
All right. Okay. So everyone looks good on this. Now it's that big thing that we had a little bit of trouble last time with.
But we figured it out.
Yep. So
Eventually.
just try this again this time. Do we need the formula written somewhere again, or the formula?
Look at it. Fake it.
I mean, I can write it again. Really, do you have an extra marker? Okay. Let's see. I will just
Could you just type it in the bar? Oh, we didn't. Look at it. I will be the teacher. What's the equation, Luke? Current grade, 1 minus.
Basically in the final grade is equal to
Times percent final. Boom. Easy.
And basically, just a math lesson about this, that you're going to have this on the ACT, SAT,
Oh boy.
any other kind of test that you take. Basically, you're going to have remember, this is the whole thing. So the biggest thing, the total value right here, you can set that equal to basically one of your values times whatever percentage is worth towards that total value, so what percent of the total value is worth, and the other thing times the other percent. And these percentages, you need to add up to 1, which is why I have 1 minus percent. So pretty easy. I'll just cover this again sometime in your math classes. But yeah, that's basically the formula up there. And make sure when you're typing this in, don't put in this, don't put in the percent, just put PERC, because this is a remainder thing, and it also serves as this kind of weird like replacement thing in strings. So some people have this like inside a string, and then you have a string of a variable, so that variable replaces that string. It's kind of that substitution stuff. We won't cover that in our workshop, so just keep in mind that when you, if you can, try to avoid using kind of these predefined functions as your variable names. And go pay attention to what I'm writing on here. That's going to be after you're done with this. good? Questions, problems? Yeah, you can add a round function. So you have to add that to your function if you want to try that. Just do a round and then put in your variable names, which would be what is it, the final grade or whatever, on the test grade or whatever. You can do round test grade comma 2, and then set that equal to a new variable, and then return that new variable. So that would be how you would round. So use that one like new final grade is equal to round final grade comma 2. So you would set that equal to the rounded version of it, and then you're going to return the new final grade. I would redefine the function. So go back to the function and then add on the line between the return and the final grade. Everyone else? Problems? Good? Or one more time? Good? Saxon?
This line did not work.
Remember the multiplication? Same thing last time, right? Yeah, it's like in math you have abbreviation. Maybe I should put that there just so we all know. So remember to have your asterisks when you're multiplying, even if you have parentheses already. So like that.
I put it head down since I at the end.
So you need double parentheses, right? Because you have one at start, so you wait. So okay.
Oh.
So you have this.
And then I
You have two. You closed it. You don't need this, right? Because yeah, just leave that parentheses. And then, parentheses get pretty confusing sometimes, which is why sometimes people break up by 2 lines so you don't get caught up with a lot of different parentheses. Is it working for everyone now, or?
I think I got it, yeah.
Good. So right now you round it, right? It doesn't do anything. So right now it doesn't have anything. It just does print out whatever you had before. So because you show returning final grade, so if you look at what you're seeing, right now it's saying I'm going to find final grade and I'm going to print that out. So it goes back to final grade's right here, right? Let's see that one, final grade. What you wanted to do then is to print out this, and you should probably have final grade here, right? If you try to round this number. So the final grade here, and then set this equal to x is equal to, you said new final grade, right? Around the final grade, set that equal to this. And that way, this is a data value, so you store this data. Yeah, x equals, or whatever variable name you want to give it, equals, and then you set it equal to all of this. And then you return just whatever variable name you have right here. So make sure that for the final grade instead of 1. So one more thing to keep in mind, guys.
Alright, don't come back.
One more thing to keep in mind, guys, is that you can always set a function equal to a variable. So when you have something like round or you have a final grade calculator. You calculate final grade and you have parameters. You can set that equal to something like x, and that would store whatever you have as a number. So let's say you have a function, and you don't just want to calculate final grade. You want to accumulate all those final grades in a list or something. So you can get all the possible final grades in all your classes and then average them. So you can tell yourself, what's the average final test grade that you need to get in your classes to maintain an A or a B. And if that's your goal, then you're going to have a list, and you can set each of the items in the list equal to each of these functions, and then you change the parameters of the function. So that would be like x is equal to da da da, y is equal to calling the function or parameters, z is equal to the function, and so now parameters for a different class, and then you can append those to a list, which is something we'll cover pretty soon. The append function is pretty useful. It's a little bit more convoluted than these other functions, but it's a very powerful function that people use quite a bit. But anyways, everyone is pretty good on this so far? Okay. So here's your next task. You haven't seen this before. So basically, it's activity number 2. You have a list of integers, right? You don't have to write that out right now, but you're given a list of integers, and your goal is for any list of integers, no matter how big, you want to be able to create a function to separate or parse the list into 2 lists. So that's a number 1. Actually, you can call this number 2, second step, okay? So this is your first step down here. So work on this first because you don't have the materials for this yet. That's where the append function comes in handy. But right now, you want to be able to print that the number is either odd or even. And you want to make sure this is the number itself. So if you were 5, it would print out 5 is odd, okay? And so just a hint about this, use some if loops like we did before, and then you got to be creative. How would you tell if something is an odd or even number? And you can think about this. What kind of tools that you have so far? How can you differentiate? And this is one of the tasks that is used a lot by beginner programming classes to teach their kids how to think like that, because there's not a function that tells you it's even or odd, and it seems like a very simple problem, and you got to think about it. So give you some time to work on this. So just number 1. Don't work on number 2 yet. So work on number 1, and then we'll get started. And I'll put the directions on a new slide up here. Huh? Oh, you just develop a function that will take a list as a parameter. So you know how before we used single variables as the parameters? This time your parameters are going to be a list. So whatever you set up there, that's going to be your list name in the parentheses for your function. So just think about it. If you're stuck on the first step of defining a function, I'll help you guys out really fast as soon as I get this written down. So basically, problem. So that's your problem up there, in case you want to do that. That's the problem you're solving for. And then we'll go tackle number 2 as a team together. So that's going to involve a new function that we're going to cover. So try to do number 1. I'll give you guys 5 minutes, and then I'll help you guys if you're still stuck, because it's a bit more challenging than some of the other ones. So not just the if loop, remember you should add a for loop too. If loop inside a for loop to be precise. Kind of like, and I'll go back to the slides, so this might give you a good example of how you might want to set it up. It's going to be very similar in structure, but you can kind of do that creative part of doing the how to filter odds from evens.
Wait, do you write a name to the list at all?
Yeah, so you could just say define your function name, parentheses, just put in list. And then if you're going to iterate over here, you could say for x in list. And this is not a function I have right here, but this is just a loop example. So you're going to have the function kind of structure to it, and then put this inside of it. Everyone looks pretty stumped so far. So let's go around. What are the problems you guys are encountering right now? Like, is it?
I feel like I'm either right on the verge of it or completely out of left field.
On the
But what I want to say is like for number and list, if the number has a remainder of 1,
yeah, that's a good one. That's one way you could approach it.
what I want to have is if it has I don't know how to write if it has a remainder of 1.
Mm-hmm.
And so I'm figuring out how to work that.
Yeah. Takes a bit of thinking. Luke?
I'm mixed up on the if x is equal, like how would I?
Same place as Saxon. Yeah. Tony?
I'm stuck on how to do the if. Like, so you start with the for loop.
Okay, so everyone, you're going to put a for loop first, and then you tab your if loop inside that for loop, right? So make sure the if loop is basically double tabbed because you have a function, and then your for loop is going to be tabbed, your if loop is going to be double tabbed.
It's just giving me an error.
And you had to have colons, you remember that.
I'm saying syntax error.
Saxon, I'm going to give you a little hint real fast. Okay? Actually, I want you to think a bit more, and then I'll give you the hint. You're so close to it. I'll go with Tony.
It's the exact wording I'm struggling with.
Yeah. I'm going to give you a hint. You're thinking of it the opposite direction. You just reversed the logic. You get it. Remember, you can't just set equal to, okay? That's another trick Python. If you want to say something, if this is equal to, it's a double equal sign. So I'm going to add this to my slides because that's another confusing part that we have. So,
Python, why are you confusing?
math calculations. Is equal to. That's your is equal to sign. So we want to say if this is equal to double equal sign. So you can't just have one equal sign. Because one equal sign is meant for instantiating stuff, not for saying is this equivalent in value to something else. And all right, Saxon. Here's my hint. What if you? This is hint to everyone. Okay, so we can. What if you set the remainder not equal to 1 but equal to 0? Zach.
I need to figure out the syntax, but I think I got it.
Yeah. See, if you set it equal to 1, you know that if you divide something by 2, if you divide something by 2 by odd, you can also set that equal to 1 in that case. But if you divide something, you can also change it around and set it equal to 0, which is what I would probably do first. That might be a bit easier to net it because it's either even or odd, right? So if you set out the evens, which by definition of even is, because the formal definitions of evens and odds, even numbers are stuff that basically can be broken off into two groups. And odds are numbers that are not even. So first net for even numbers, then you can net for odds. You could do the opposite way too, but it might be easier to do evens first and then odds.
How would you like incorporate the remainder? Would you give the number and remainder to?
Yeah. So like you have something like for x in list colon enter tab, then you have if x remainder 2 or whatever is equal to 0, then you're going to go in the tab and print whatever you want to print. This x is, and make sure it's string x, so you're casting it into the string so we know what variable it is greater than, not it's greater than, is even. And then you can just do an else statement afterwards and say it's odd, which will work as well. Some of the simple stuff, I guess.
I thought you only did that for the first one, though. For like the for ink.
Yeah, for and but remember, every time you use for, if, or a function, you're gonna have Coolhead whenever you want to tap into it. But whenever you're gonna have to tap into it one more time, always put a Coolhead. If x returns odd, return. And one more thing, distinction between return and print functions. Return function, what it will do is will print out whatever it is, or it will, you can set it equal. It's going to give you, it's going to spit out that output, that value for you, but it's also going to stop the function. So in this case, you don't want to use the return function. If x is x remainder 2 is equal to 0, you don't want to return a string. You want to print that string, so you can keep moving it on and on in your function. Because if you return it, it's going to stop right there and be done with it. If that makes sense.
Okay, so I don't, this is what I
then you basically put everything here and tap it. So odd, even a unique parameter too. So to be the list or the list. And print all that will only print it out. So you want to print out this. You want to print out X actually, right? So that's a variable that's going to be individual member in the list. So you want to print X, but you also want to tell me that if it's even or odd. So how would you do that? So what I would do if you want to look up there, super almost close to the last time, which is print string X plus something. So that's one way you could do it. If you want to just cast. So right up here you have just integers, right? Just integers here. If you want to cast integers into a string value, so then you can add it to different strings. So basically combining two phrases together, then you can just say string X plus, page marks is even inside the quotation. So if you do that, then it's just going to print out whatever the number is even, and then you want to do a second if loop, if statement, or you can just do else, because if it's not even, then it's going to be odd. So you just do else, and then you can say print string X is odd plus page mark is odd. So kind of like a format up there. So like if you for print, if you want to cast it into a string value, remember that function string, and then you can cast X, right? Or so now you can add it to some other string, and you can just write a new string, whatever it is, and you can put marks like that. And then afterwards you can do your else statement for that. Yeah.
All right. So I got here, and it said return is outside function.
Okay, so you want to do a print here. So
Why?
because okay, so think about it this way. Right? Okay, I'm not sure if this is where your syntax error is. Okay, so okay. It's outside of the function because you don't want to be returning within two tabs, if that makes sense. Like it's right now inside this else statement. Wait. Not sure. My guess would be that either, I mean, it should probably be that. Whenever I return something, I never use the intermediate stuff like this. So I would set this equal to something that I return. Does that make sense?
That was equal.
It's just X is equal to all this. And then return X. It's like an extra step. It's the same thing, but usually return you want to return just a variable, not like some kind of command or something. I could solve it, but keep in mind that when you return something, it's going to in that function, right? So for a number in list, example, this equals the first number, says, oh no, it's not this, prints this out, and returns, and then stops it. So once you hit this thing, it's going to stop it and not cover the rest of the numbers in the list, right? So if you instead you just use another print function here, then it can keep doing that. So you don't always have to have a return in a function, but especially for these kind of like surveying kind of functions, you don't usually need to use return. But when we get to step number 2, which I'm going to walk you guys through, that's when we're going to use some return functions. Solid, looks pretty good. Finally.
And the else command
okay, but remember enter is like if. Go there, see the else, enter, and then you have your just print. Basically the same thing you have over here, but is. Well, you want to put is using, right? And then you just put is all out there. Make sure you have your task your X and your string as well.
Everyone seems to be finishing on time now. It's pretty good. That's usually one of the first problems that a lot of people, especially in those introductory kind of programming classes, that's usually one of the first problems that make you solve, or that'd be like a good test question for people in those classes. So it's really, really important. All right, so everyone seems good. So how you solve it, everyone seems to get it, is you have a for loop, and then inside of it, well, you first define your function, one parameter, that's going to be a list name, and then for some variable in your list, you're going to, if it is, if x, if you call that your variable, remainder 2 is equal to 0, which is double x equals marks, then you're going to print out string x plus a string that says is even, and then you do else, print out string x is odd. So that's basically the rundown. Everyone seems to have a good idea of how to do this. So just a quick overview. How do you guys feel about writing your first independent little program? That's pretty good, right? Yeah, so these are, that's what programmers do on a daily basis, just like small problems like this, and they seem really simple, right? Like, oh, I could tell odds or evens. And you might be like, why do I need to write a program for this? If I could just take a list of like odd, even, I could do it faster that way. But what if you had a list that was 10,000 integers long, right? You would have to pay a lot of people a lot of hours just to separate that. But if you have this function, you can write down. How about right now? You guys just write down a big list of as many numbers as you want, and then see how it works on that. And it should be very, very fast. It should be almost instantaneous and just boom, out there for you. So, yeah.
If you want to, how would you make this? How would you define a function to have the function to do this with new list? We just put define function in front of everything.
Let's see.
Like if you want to have this function for future lists.
Oh, so you just had it so far in this, okay. So you have a defined function, right? Just define whatever, and then you would basically have all this inside of that function, okay? And just call it in lists, just this order, even or something like that, and then your parameter is just going to be list. You can put colon, enter, and then you have everything here, but they're going to be shipped in one tab.
It would just be list.
You just call it whatever, list, you can call it number list, just anything that makes sense to you. Then make sure you tab everything over once, and then you call upon it over and over again, and you put in a new list every time. You just enter right there, not a loop. Enter. You just try it. If you just want tab and then enter, I think that should work too. You don't want to shift all the way back.
Okay. Like auto pushes it back.
Yeah, well, because like you have just hit tab and then enter.
At the beginning.
So no, like when you're after you tab it, you don't have to like move all the way back to my center. Does that make sense? Because I know like word processors, if you hit enter like halfway in the middle, it's gonna like separate the lines.
Well, here, where do I hit tab a bunch of times?
Well, like so like if you
Yeah, go up with the there.
else. So if you hit else and you want to tab it, you just hit tab
Oh.
and then enter. So you don't have to like just go to the very end and then enter. It might save you like a few seconds. It's not a big deal. Okay, third.
Working.
Pretty cool, huh? So you got an ASCII list, whatever, it's going to separate off faster than the kids you can.
Yeah.
That's a cool video game, right?
Yeah, cool game.
should use brackets if you're doing this, right?
Using these new numbers.
Looks like it works. So that's basically why functions, computer programming is very useful, and especially functions because you can do it to lots of different types of things. Now let's work on, let's see, I'm going to search a new slide. This is going to be called activity number 3. So you guys already kind of have the structure for this already out. You can make a few edits to yours, and then you can do some pretty cool stuff with this. So it's going to be, let's see, create a function to separate, which is also known as parse. That's the computer programming term you use. A list into 2 lists, one for odd numbers, one for even numbers. Okay. So based off what you guys just did right now, how do you think you can alter your program to do something like this? And there's a command, it's called append, that you guys haven't learned yet. But like, kind of, what would you do if you could like physically like do stuff with it? Yeah, you would use same commands that you have right now, like the if commands. But then instead of printing it out, what would you do with it?
You would put a command that I'm going to assume is parse into like list 1, or parse into, like parse into list 1, or
Yeah.
else parse into list 2.
Okay, that makes sense. And then what would you do at the very bottom? Instead of printing stuff out, because you want to return a value, not just a line of like a sentence or something. You want to return a number or because you want to turn 2 lists. What would you have in the end?
Return list 1 and 2.
Yeah, you would return a list of lists, I guess. Will be one way to put it. Or you could return 2 separate lists and then set 2 variables equal to each other. So how that would look was you x comma y is equal to where function, this is function name, and then you have whatever list. So you would return basically in your function at the end of it. You would say return list 1, list. I should probably do this. List 1, list 2. Okay, so you're returning 2 lists, so you kind of set 2 variables equal to it. So this is why you have this. So that's kind of convention. That's not, doesn't happen too much, but that's one way to do it. So hint append function. You're going to use something called an empty list, and just take a guess. What do you think an empty list is?
A list with no variables or data.
Yeah. How do you think you would instantiate an empty list?
List is equal to, again, just say 0.
You could. It would be something like this. So just like open bracket, end bracket, just done. I actually use that quite a bit. It comes in handy quite a bit. So list is equal to. Does anyone have the time? How much time do you have left?
It is
5 minutes left. Okay, I'm going to walk through this real fast for you guys.
Oh boy.
Okay, so just some food for thought before you leave. And then next time we're going to cover this in more depth. Maybe try to ask you guys to reproduce some of this stuff, and then we're going to go back to my gene analysis algorithm. We're going to look at that, and hopefully by then you guys should have a pretty advanced basis in Python. So these are the hints I'm going to give, and then I'm going to start. All right, let's go into Python. Python, we're going to define a function. Let's call it odd, even, and we're going to take in a list. Tab. For x in list, if x is x remainder 2 is equal to 0. Okay, I made a little mistake here, so I'm going to redo this. Okay, so I want to make some empty lists because I want to append something to a list first. I want to, let's say, odd list is equal to even list is equal to if, I'm just going to, now we do for x and whatever. Well, this is what you do. You put the list name first, odd list, right? And you guys can copy it down in your notes. I'll put it on the website too. I'll copy this into the notes and then upload new notes to the website, but try to copy them down in case I don't do that or I forget about it. So odd list dot append. That's how you use the append function, and you're going to append what to it? You're going to append x, right? Because if x is, oh crap, I need to tab this in. Okay. Now, else, and this is going to look very familiar. This is just like your function you wrote, but you're going to say, well, that's not odd list, that's even list. Excuse me. First one should be even list, not odd list, but I don't want to redo it, so we're just going to call this real, no, we're just going to call it even list. Okay, so even is odd and odd is even, okay? Just keep that in your mind. That's the append function. That means you're going to add whatever's afterwards in parentheses to that list. So it's going to add it as the next item in that list. So basically, let's say append x, okay, and then you're going to return, and return is going to be out here because it's going to be the first level of the function, and you're going to return your two lists, odd list, even list. Actually, we could do something here, and I'm going to call it odds is equal to even list so we don't get confused. And then evens is equal to odd list. And that's because I messed up at the start and I don't want to redo it. So you don't need to put this in your notes. Just make sure you have the even list dot append and odd list dot append switched around. So it should be even list dot append. Another if is x, if x remainder 2 is equal to 0. And or else it should be odd list dot append x. So just as long as you get those two fixed, you should be good. And then return, I'm going to do odds first and then evens. So you would put down, instead of this, you put odd list, comma, even list. Okay, if that makes sense. Anyways, enter, let's call upon this function, odd even, or we'll set it equal something. X. Yeah, so it should be even list dot append on the first one instead of odd, because I just wasn't thinking straight and put odd instead of even. And the bottom one should be odd list dot append. And then you can skip the other two, so where the odds is equal to whatever. Just return odd list and then even list. And then odd, even, and let's give it a list, guys. 1, 2, 3, 4, 5, 6, 7. All right. Let's see if this works. Okay, so right now it looks like it didn't work, right? But what really happened was that I stored each of those lists into these variables. So x is now equal to the list of all odds. Y is equal to the list of all the even numbers. So it might not look like a lot, but now you have them stored and you can do a bunch of stuff with them, which is better than just printing out the values once. So you can print x. Look, those are your odd numbers in this list. You can print y, and that's a list of your even numbers. I know this is kind of fast, just think about it. You're not supposed to learn it today. We're going to cover it again in more detail. Not next Wednesday, actually, because next Wednesday is like Labor Day or something, or Memorial Day. I don't remember. But it's a national holiday, and the library is going to be closed, so we won't do it next Wednesday. But I might post a video on this, maybe. Or I'll post this video onto the YouTube channel, so if you want to re-watch this to kind of maybe understand what's going on up here, then feel free to do so. But quick, I'm going to copy all this, so kind of see what happened there, right, everyone? Ish.
How would you just call odd even list?
Huh? So yeah, you would set two variables because you're going to be returning two lists over here. And in your case, it would be odd list, even list.
So
X, Y, you can set it. You can X, Y, you can do anything else you want to do, but just make sure you separate them with commas. And that way you have two variables now that have been instantiated, and they're two list names that have been instantiated. Now you can print them out whenever you want. You can do other stuff with them. You can throw them into other functions if you want. So I'm going to add this to the slides real fast. So, file. Solution. Okay. Right. Okay. Alright, so it should be something like this in the end. Feel free to write this down, or I'll have it on the notes. So that's basically what you're going to be doing. I'll leave this up, and then if you want to copy it down, look it over before we meet next Friday. Or let's take a. Do you guys want to meet on Wednesday, but at the high school? Maybe. I'll let you guys know by email if before Wednesday comes around. So at the latest Tuesday night, if I can find a room at the high school after school. If anyone wants to show up, then we could go over this again. Okay. So yeah, I'll see if I have time on Wednesdays or it works out for everyone. I'll send out an email before then, but count on not going on Wednesday right now. And if there is an email, that might be changed. Okay. So is everyone good on this, or do you guys want some more time to copy it down, look at it? Everyone good? Saxon good? Everyone else good? Okay. Everyone kind of understand how it works a little bit? Kind of at least the theory of it, maybe not each individual thing. Theory. Okay. So it's kind of like your thing, but just the only difference is that you're going to instantiate some blank, empty lists in the start because you want to append to them. You want to add some more values to them so you can, after they're complete, then you can spit them back out in the complete list. And then over here, instead of printing out the number and saying it's even or odd, you're going to append, which is basically you're going to have a list name, dot, append, and then in parentheses, whatever variable you're going to append to it. So you're appending even if it's even, it's even list, odd if it's not even into the odd list, and then you return the odd list first, then the even list, meaning that the x is set equal to the odd list, and the y is set equal to the even list. And then you can just print y, print x like I did over here. Print x, all the odds, print y, all the evens, right? So that's kind of how you would do it. All right, I think that's it for today.